node, it is the description of a node. Resource oriented, I think, means that it's basically an amount of tokens, for example. That's what I read out of the document what you wrote.
Okay.
That's interesting. So I'm failing to see how that's a totally different kind of programming language type just based off that. But maybe if we get more into cadence at some point, it'll make more sense as to why. But it could just be a business thing. It could just be, oh, we want to be cool. And
Yeah, so basically what happens is that let's say you found your own startup, you get seed funding, and then you go to Series A, Series B, Series C, and you will meet different kinds of people with different the backgrounds at each series. So there is a certain series when you need to sell stuff with this kind of jargon, with this kind of people, and then as you go up, you will meet different kind of people, and you need to sell your stuff a little bit differently because the stakes are higher. That's what I think it's what's behind it. So I feel that this was a Series A or Series B kind of fundraising for Dapper Labs, and what that meant is that they have to sell themselves to the PhDs.
yeah, we created a whole new class of programming languages.
Yeah, CSPhD.
Yeah. That was my impression. Yeah. But I don't want to be overly judgmental until I actually try to do something.
Yeah. It's a company at growth. They don't have profits yet. They don't have any income, net income. They probably have some revenue, but they have growth. And the language, the jargon that they use, basically define what scale they can reach. So if they say, okay, we invented a process development or a software development process. We invented a new programming language. Then you are at the scale of Facebook, for example, or Microsoft. If you say that you are a finance company, you are kind of like a scale of Salesforce. So it's kind of like or a target for Salesforce to be bought. So that's what it is about.
Yeah, you have to make sure it sounds good so you can get maximum income.
Yeah, so that they can assess what's your potential. Can you be the next Facebook? Can you be the next Cadence? That's a hardware company. Can you be the next Xilinx, or can you be the next Twitch, for example?
I didn't even know about the Cadence hardware company until you asked me about it. And I looked in and I was like, oh man, that's really confusing.
I think actually while I saw that while I was reading the source code, it was actually written at the very beginning or designed by someone who has hardware knowledge, which is not uncommon if you do crypto, because they have to design specialized hardware to mine or basically generate these hashes. And then Cadence is one of these environments where you simulate a new hardware.
Wow,
it's super expensive. It's like a big box in a room. Only 2 engineers can use it during the day. You have to reserve it like the old IBM machines, as it's super expensive. It's like gold. Every single minute is gold to use those kind of stuff, but they are very, very
seriously, man. You're like going back to the old mainframe time sharing days. The way you're talking about it.
No. This is a hardware simulator. So it basically simulates an Intel processor or an AMD processor. So this is that kind of environment. So basically, creating a new processor, if you send it to TSMC, and let's say they print 100 processors for you, so that you can check your new design. That's super expensive, millions and millions of dollars. So instead of that, or before you do that, there is another step, and this step is running it on Cadence.
It's like a testing. It's like a processor hardware testing machine, basically.
Yes, it's like a cloud. It's just way faster. So it's designed for hardware simulation.
Okay, I see what you're saying.
It's like the GPU.
If you want to put out a new chip and you want to make sure the internal architecture works, instead of printing it and then you spend millions of dollars and you're not even sure, you can test it in this supercomputer, basically make sure that all the internal architecture is going to work with whatever.
Yes.
Yeah, that makes sense. I didn't know about that, but it makes sense now that you explain it. So with Solidity, what the smart contracts do, and we'll get more into that, they control various account actions on Ethereum wallets. It's statically typed. It tests and enforces compile time limits as opposed to runtime limits, and it was launched in 2015. So this is how they write smart contracts. This is what they claim that Ethereum's backend is designed in, but basically it's just designed JavaScript and C++. But this is basically almost like a library, which is based on these two just to make it easier to construct dApps with pre-built phrases and expressions so that you can have them execute and you don't have to have a huge software development experience to be able to work in it. So what are the variables that Solidity has? If you have questions about this, I'm just not gonna be able to answer them because I haven't gotten that deep into Solidity. So it has 3 variable types: state variables, local variables, and global variables. State variables are stored permanently in contract storage. Local variables are present before you execute. And then global variables are generic namespace that just give you knowledge about the entire Ethereum blockchain itself. So then there's statically typed languages. Oops, nope. It's a statically typed language. And so you define the state or local variable during declaration. Every declared variable has a default value depending on the type of the variable. There's no undefined or null function for Solidity variables. You can change variable accessibility and control who has access to variables. So it has pretty similar parameters to JavaScript, and it only supports minimal arguments for its events. So that's Solidity variables. Hey, Pradeep.
Hello, hello. Sorry, I joined.
So what are the function types in Solidity? We'll look at the reference types, which are arrays, structs, mapping types, and there's key value pairs, and then value types. So arrays are sets of the same type of variable. Inside of arrays, there are indexes, and every particular variable has a specific location. They have attributes, which are accessed by the index position, and then the array scale can be set or adjustable. Then there's structs, which is a Solidity thing, allows devs to build their own structure types, represent value types, and reference type variables. Then there's mapping types, which is the most widely used reference type in Solidity, which stores data in a key value pair. It could be either a built-in value or a byte string, so it can be obvious why we need key values for something involving blockchains, like a hash table or a dictionary. So it could store key value data, and it could be retrieved by name, account name. Then there's value types, which is the only difference between that and reference type is the data location. Arrays and structs have additional data locations, and that determines where variable values can be stored. Okay. So if you ever decide that you want to pick up Solidity and become a Ethereum dApp engineer, then you learn to here first. So how are smart contracts structured? So this is an example of just a tiny section of a smart contract. Solidity contracts are structured similar to the way that stuff is structured in object-oriented languages. So some of the things that you can include is state variables, which are quantities stored indefinitely in contract storage, functions, which is the actual executable part of the code, other functions which modify the semantics, declaratively, modifiers, events for EVM logging services. So that's where they see what happened. Struct types, custom specified variable groups, and enum declarations, constant values to construct custom data types. And contracts can also inherit from other contracts. Function modifiers can be used to modify function semantics in a declarative manner, and events are channels of comfort for the EVM logging services. So I imagine as Flow grows, there's probably going to be a huge market for Flow cadence developers, which just means no JavaScript and C++. So I'm sure knowing Solidity would definitely give an advantage with regards to that. So that's it for Solidity. I see Jim yawning over there.
Sorry, man.
It's
Not
okay.
that this isn't interesting. I'm hitting my wall in the afternoon here.
Yeah, I know.
Late night and early morning.
Getting late. So let's look at CLIs that Ethereum uses for development. So IT professionals and developers are fond of the terminal, especially I think Miklos and I both like the terminal because we deal on Linux. So there has to be some CLI programming tools so that there's a full environment for creation and testing. Ethereum-based apps. So there's three major Ethereum CLIs: Truffle, Embark, and Dapple. So Flow itself also has a CLI, which we use, and it's maintained entirely by Dapper. So over time, probably there will be more sophisticated open source CLIs that come out from the community. So Truffle is a CLI programming platform, which gives you a full environment for creating testing applications. It gives you a testing framework and asset pipeline, so it just makes it easier to be Ethereum dev. It's maintained by a company called Consensus. It has built-in compilation, connection, and deployment smart contracts, automated testing of contracts with Mocha and Shy, which are two testing frameworks that they have. Has a configurable build pipeline and custom build process support, framework for scriptable deployment and migration. It has network management tools for deploying various public and deploying over various public and private networks. You can rebuild assets, and it has an external script runner, which runs scripts in a Truffle environment. So then there's Embark and Dapple, which are two other CLIs. So Embark is a platform for making dApps easier using serverless HTML5. It incorporates Ethereum, incorporates IPFS, decentralized storage, and it incorporates open networking, Whisper and Orbit. Also has Swarm. You can install contracts automatically, make them available in JavaScript. Embark also will watch for updates and redeploy the contracts if there's a problem with them, which you would want to do in the testing environment first. But if there is an issue, then you can redeploy. But it's going to have to be a different contract from a different address. Test drive contract creation with JavaScript, keep track of ones you've already deployed and execute when you need them, and then save and easily retrieve it with Embark JS on the dApp. You can also, as we said, integrate it with IPFS and manage dynamic interdependent contract structures. So if you have contracts that are dependent on other contracts, Embark helps you manage that. Dapple is another CLI, but there's a new one called DApp, which is used, but it's the same thing. It's a CLI for smart contracts, and it helps you manage package, create code, unit test, and implement. So those are the CLIs for development. But then there's also Ethereum IDEs. So the first thing you do when you can develop an app is just outline the basic logic. And then you can look at putting it in an IDE, in an integrated development environment, which helps you with development speed, your velocity, and to make things streamlined. Also, if you want to work, obviously, with other developers simultaneously on the same thing. So they improve efficiency, they reduce startup time, they speed up production activities, they keep developer environment up to date, and they standardize development processes, especially if it's integrated with whatever is the end product that you're working on. So the most prominent one for Ethereum and Solidity is called Remix, and there's another one called Ffiddle. So Remix is web-based, and so is Ffiddle. They're both based in the browser. They're targeted at Solidity and Ethereum development. And previously, this kind of thing was called browser Solidity. So it helps you compile the code with current compiler versions. You can check the code across all the networks and ecosystems for Ethereum. You can customize it. There, you can run the EVM in JavaScript, so JavaScript virtual machine. You can have it embedded with Web3.js integrated framework for smart contracts. This is very cutting edge stuff. You can also import, integrate with GitHub and Swarm, but it's kind of difficult. It's hard for beginners to get in. So then there's Ffiddle. It has more lightweight features, but it also has better code presentation. It's designed to make it simple, so it's easy to embed and upload apps, but it's not as rich or as quick as Remix. So this is a picture of Remix IDE in the web browser. You can see there's a default workspace, contracts, scripts, text, README, so on and so forth. It's free. You can just go in there and use it and run your code. And then this is a picture of Ffiddle. So you can see it's a simpler interface, but obviously there's not as many options. As you see, there's a security audit over here, recent fiddles, so on and so forth.
Okay. And again, these are just on Ethereum?
Yeah, these are just for Solidity, for Ethereum smart contracts. Yep. Okay. So then there's code analyzers. So what is a code analyzer? when you have a decentralized network and you're putting out a complex smart contract that is dealing with people's financial data and maybe has dependence on oracles or other smart contracts, and there is no official testing environment, you have to use a test net and do it on your local net first and then put it on your test net, so on and so forth. And storage and possibly data which should be legally protected. This is all really complicated and there's a million things that can go wrong. And in Ethereum, unlike on Flow, there's a way to basically push a software update to your DApp or your smart contract. You can't really do that in Ethereum. In Ethereum, once it's there, it's immutable, and it will be executed as is. So if you have something which is faulty in the smart contract, it could result in losses and permanent losses at that. So Ethereum has their code analyzers which are built specifically to help developers write safe and stable code. So Solium or Solium, I don't know how you pronounce that, and then Open Zeppelin. Solium was released in 2016. It helps devs write solid, safe smart contracts, and it acts like an interpreter. Basically, it reviews a code for style and security issues, and it was developed exclusively to follow Solidity's official style guide originally, but now you can customize it according to your own style guide or your style and security needs. So it analyzes your Solidity code for design security problems. It standardizes smart contract activities in an enterprise environment if you have a company which is writing a whole bunch of these. And you can also incorporate it with your build infrastructure to securely launch smart contracts. Then there's Open Zeppelin, which is also Solidity framework for secure smart contracts. So developers can create distributed systems, protocols, and even entities. We haven't talked about decentralized organizations yet in Solidity. Another cool thing is that it actually integrates with Truffle. If you remember the CLI from a couple slides ago, Truffle, wherever it was way back over here somewhere. It actually smoothly integrates with Truffle, which is super convenient. And when you write your contracts in Open Zeppelin, it helps to reduce risk because you can battle test them. They actually have libraries which are battle tested, which they've tested again and again, which are available that you can just deploy and stick that stuff in your code. It integrates across ERC standards. We haven't talked about that yet, which we will we'll see if we get to it today. And also helps companies run security checks or audits on their smart contracts or their tokens. We haven't talked about that yet. Access control, decide who on the network will actually get to execute the contracts, tokens, we'll talk about that. And then gas station network, which allows customers to use contracts without paying for the gas that's normally required in an EVM. So are there any high level questions about the stuff that I've been droning on and on about? Ethereum development. So Ethereum development has definitely some major parallels with Flow development in terms of clients, observer service, CLIs, Flow CLI, EVM, execution nodes / access nodes, so on and so forth. So there's a lot of parallels. So if there's no questions, we can get on the ERCs.
Here also we have something similar to the local net or the test net. Ethereum also.
Yeah, so Ethereum has both a local net and a test net. So the test net is primarily for testing smart contracts, but they also have local nets with RPC interfaces. So it's basically the same setup as Flow. So they have local test nets and then they have emulators. So Flow also has an emulator. Emulator is just like a really lightweight simulation of the network. Then you have a full local test net, which is supposed to be emulating an entire Ethereum network on your device. And then there's public test nets where you can actually deploy smart contracts and it will behave just like the same Ethereum network. So Flow has the same thing. Flow has the emulator, and then it has local net, which is what we develop on, and then it has test net. And then in terms of like what would be the client equivalent in Flow, the equivalent of a client would be like an observer service. So we really are kind of making the client. And then the equivalent of the EVM which Flow actually has a Flow virtual machine, but it's kind of a different concept. But the equivalent of this would be like an execution node / access node. So the functionality is kind of divvied up, if that makes sense. And then the equivalent of Solidity is Cadence. So there's a lot of parallels for sure. I don't think there's any smart contract code analyzers for Flow yet. Not that I'm aware of. Unless our integration testing gets to a whole another level. So ERCs, what are ERC standards? ERC standards are very similar to flips. A flip is on Flow, which is a Flow improvement proposal. So there's a concept in open source of a request for comment or a request for improvement or a proposal where somebody in the open source community sees something about the code and they submit a request to change it in a way that is significant, which they believe will improve it, and they submit it, is brought forth the community, and there's various ways to vote on it. So Ethereum has ERCs. What are ERCs? They're created by programmers on Ethereum, and they lay out various things that people want to see in Ethereum, which could be changes to Ethereum's network, fundamental protocol changes, or it could be defining how certain things happen on Ethereum. So Ethereum did not always have non-fungible tokens or other kinds of tokens. That was something which is invented. So once people decided that they wanted something like that, they had to request the change to the network to be able to support it. So some ERCs deal with application level software, token standards, library standards, package standards, name registries, and even other stuff. Anybody can propose ERC, but when you write your ERC, you have to explain what it is, and then it's your job to get community support around it so that somebody actually wants it. So what are ERCs really famous for? They're famous for defining how crypto tokens are supposed to behave and how smart contracts are supposed to work in a predictable way. So they standardize, hey, these are the ways that these kinds of tokens and these kinds of smart contracts should work. So all of them necessarily, because of what they are in proposing changes, they require some kind of strictures and rules, which means that some stuff is not going to be compatible with it. But ERCs are also supposed to end up having libraries around them, so developers don't repeat themselves because there's pre-built libraries that they can follow to standardize stuff. So it helps developers in deploying smart contracts with standard applications quickly. Token contracts, ICO, crowd sales, escrows, tracking stuff. And then there's wizards and Oracle networks, which can be built on top of a particular app smart contracts. It helps in user interface development, workflow creation process. So there's something called Ethereum Improvement Proposal System, which is where you put your ERCs, kind of like the Flow Improvement Proposal System. And then Ethereum community reviews those documents, and then the community can ask for revision at that stage. They can vote on it, comments, so on and so forth. And then if it's accepted, it's put on the network. So this sounds kind of high level and abstract. There already are. So why is this important? This is important for two reasons. The first reason it's important is, and the most obvious reason, is that Flow deals in Ethereum tokens. So you can buy and sell and deal with Ethereum tokens on Flow as it is, and they're probably going to support that forever. So you have to know what these tokens are if you want to be on Flow, and especially if you want to write smart contracts or if you want to own anything on Flow. And so this is what the end user is going to, one of the main things the end user is going to end up using. Another reason why is that Flow have their own improvement proposal system and request for change things. So right now it's done just by putting issues and just changing it directly, but over time it's probably going to become more formalized. So any questions about ERCs, the basics of ERCs? We're going to get into various kinds of ERCs more in depth.
Nope, I don't.
Okay.
Very effective teaching.
Thank you. Appreciate that. Okay, ERC20. So ERC20, when you hear ERC20, just think of initial coin offering.
Actually, I do have one question, Ollie. So what I just heard is that you use Ethereum crypto on Flow for your transactions.
So hypothetically, and I don't know how developed this is because I haven't had time to just sit around on the user side of things on Flow, but the end vision for Flow is that your tokens in crypto are no longer confined to any platform. So you should be able to have a Flow wallet and have Bitcoin in it, Ethereum in it, Ethereum tokens, Flow tokens, a smart contract from whatever other blockchain, and you should be able to have it all in one integrated wallet. And they have this concept of a vault where you just have it in your own wallet and can access it wherever, and nobody is ever in possession of your data at any time. You have it and you choose where you want to deploy it, and it's all totally integrated. So that's kind of their whole Web 3.0 vision. That's like how they see the future. They see the future not in databases or websites or social media platforms. You have total access and ownership of all of your virtual assets individually in a decentralized fashion, and then you choose to integrate them with whatever platforms or services that you want. And so right now, Flow supports ERC tokens. You can get a Flow wallet and you can send your Ethereum tokens to it and manage it from there.
Okay. That's very
So-
interesting. I did not know about that. Like, but how does that work when you're trying to stake? Is there like a currency conversion or a crypto conversion algorithm that's going on to translate values between these different cryptocurrencies?
So I don't know. I know that there's an indigenous Flow token, but I don't know whether they like value your other stuff and then use that for staking. I imagine probably not. You probably wouldn't need to use the indigenous one, but I'm not 100% sure. That's more like a user side thing. So I definitely would take a look at that when we aren't knee deep into the back end. But that's a good question.
That's a
I
good.
want to know, and I have thought about that same thing for myself. So it's a very good question. It's just I haven't had the time to like sit down on the Flow marketplace and like let me see how this
the
works.
XT processor between my ears goes a little bit slower than your Pentium.
No. That's a really insightful. That was a really good question. That's a really good, and it's a practical question, and it's a question that any user would be like, "Hey, how does that work?" But
Yeah.
I haven't sat down. When I sit down and buy my $5,000 in Flow tokens in hopes that in 10 years is worth like $20 million, that's when I'll probably get to the bottom.
Your
of that
lips
question.
to God's ears. Let me say that.
That's the next step plan.
Yeah. Okay.
So let's look at ERC20 is like ICOs, initial coin offering. So ICO is when a company wants to start, and instead of selling a base amount of stock, it sells a base amount of crypto that is specific for that company and represents ownership. So this was one of the first major like super big fads on Ethereum that made it really popular. And it was everywhere. It was on the news and on the magazines. So ERC20 defines the rules for ICOs, and it's the most widely used one as of right now. Probably now that NFT token is probably more widely used, but we'll get to that. NFT standard, and it makes using Ethereum-based ICOs more efficient. It's a fungible token standard, meaning that any particular ICO unit is exchangeable for another one, like when we talked about fungibility. So it's like a currency, but not. And it allows you to create little microeconomies with liquid markets. So like you can think of this almost like Ethereum is the real world, and then when you make an ICO, it's like Disneyland. So the Disneyland tokens have a value inside of Disneyland, but not outside of Disneyland. But you can buy Disneyland tokens, and even within Disneyland, you could sell it for real money.
Okay.
So standard APIs within smart contracts related to ICOs are standardized with ERC20. Similar tokens with similar set of properties, set of guidelines for development and management of these kinds of tokens. And these kinds of tokens are traded on normal exchanges, decentralized exchanges, automated liquidity pools, and it just facilitates these with or if you wanted to run like an automated market algorithm, then this would facilitate it, because you can look at these standardized tokens, which could represent stocks or shares in a company, and they all behave the same way. So you can easily look at prices and then get a data set which is consistent and accurate. The assets are interchangeable, but they have to be used on compatible platforms. So the platform has to support ERC20 or projects or exchanges. Any DApp which supports ERC20 will be able to interact with them. And then you can track the transactions, and you can also interchange with other smart currencies, sell them, buy them, so on and so forth. Questions about ICO tokens or ERC20? So if I wanted to do a hip new startup instead of doing
Let me come back. ICO, that is that's their way to fund, the simplest of terms. And you and I have kind of talked venture capital stuff, Holly. Like rather than investing in stock, the VCs are investing in the ICO.
Exactly. Yep. And it also has a lower barrier of entry, because to get to the stock market, you have to have like what I think like 5 years of what's the documentation?
Yeah. All
You have to
that
have, like,
thrown out the windows over the last few years with SPACs.
oh yeah,
All that stuff.
I didn't know that. I might need to go start a startup then if the if the barrier entry is
Going public has nothing to do with it anymore, right? Like, yes, but there's anyway, that's a whole nother conversation for a different.
COVID messed everything up, which is good in a way. But yeah, this is a way like, okay, I have a cool company. It's usually going to be a crypto company, and I want investors to buy in. Then you could do it like this. But the other good thing is that you can do decentralized, wide scale investing. So it's almost like crowdsourcing a startup in a way, because now you don't need to go hunt down investors. You can just set up an ICO, and anybody that believes in the project can buy in early on, and then you can use that to fund your business. And then they also own a stake of your company. So this is actually how Ethereum got its funding. Ethereum did an ICO, and they raised a huge amount of funding, and they are where they are now.
Wow. Okay.
So a little bit more ERC20s. It recommended changes to Ethereum to support ICOs. All ERC20 tokens can communicate seamlessly. So there's 3 optional rules and 6 mandatory rules when you make the ERC token. You have the option to put a token name, a symbol like a ticker symbol, and then a decimal place up to 18 decimal places.
What the
You
hell
have
does
to
that
have-
have to do with anything? Why a decimal? So you can have fractional coins?
Yeah, I'm pretty sure this is for fractional components of the ICO, almost like fractional stocks.
All right.
But you don't have to have a fractional ICO per se. Like the same way you don't have to offer fractional shares of your stock.
All right.
But what it is mandatory is you have to have a total supply. How much is it? What is the cap? Transfer rules, who's approved to buy and sell it, an allowance, a balance of, and then a transfer from, where is it coming from, and then what is the ultimate balance of it. So this is what you have to have when you issue an ICO token with your smart contract, and you can have these, which would facilitate trade, but it's not necessary. So that's ERC20. There's other smaller ERCs which are not as popular. ERC 165, ERC 223, and the ERC 621. So we'll just go over them quickly.
What's the relevance of the numbers in these unusual numbers here?
So probably they just number them the way that they come in, and then just certain ones become popular and others don't. Almost like the way that GitHub works, where every time somebody puts an issue, it'll be issue number 1, issue number 2, issue number whatever. And then some issues get solved, some don't, some just get tossed out, some become popular, so on and so forth. Okay. I think on the Flow project, we have like 2097, then like 1998, and they're not in any order. It's just whenever somebody decides to put it up there, and then the community rallies around it. So ERC20, you can see was a lot earlier one. It was one of the first ones that somebody suggested, and then these come later. So ERC 165 is a standard for methods, but not for tokens, for Ethereum methods. And it discusses definitions for Ethereum interfaces, how contracts can publish interfaces after they're implemented, and it also detects when contracts implement ERC 165, so that contracts can have GUIs basically, and it covers detection of smart contracts given any user interface GUIs or CUI or CLIs. Then ERC 223, it fixes a bug in ERC 20 dealing with burning tokens. So there was this weird glitch where if you sent the token, not a weird glitch, if you sent a token to a non-existent address, it wouldn't send it back to you, so the token would just be gone forever. So if you send a token to an address which can't handle ERC 20, the tokens are lost forever. So it could even be an Ethereum address, but that address wasn't updated after ERC 20 to handle ERC 20 tokens. And so if you sent a token to it, then the token just be gone. So that was a serious problem. So developers can accept or decline tokens when they come to their address, and rejected transactions will fail and send the tokens back to the original owner. But it's still in Ethereum improvement proposal phase, so it actually hasn't been implemented. It probably has been implemented by now. ERC 621 is an update to ERC 20. It adds 2 additional functions: increase supply and decrease supply. So you can, it's almost like issuing more shares of stock, diluting it, or reducing the amount of shares, doing like a buyback. And it's also still in EIP phase, probably out by now. So there's also an ERC specifically for NFTs. So that was all for fungible tokens, but just not cryptocurrencies per se. So with NFTs, like we discussed last time, all of the tokens have unique properties, and that should have said tokens. I don't know why I wrote tickets. Have unique properties and data values. Wallets and exchanges can also reuse the tokens. I think it has been implemented now. Only 1 token per contract. And we're talking about the next ERC we're going to get into. It only creates NFTs. It's expensive in terms of gas. It only allows 1 single operation per transaction. Has high storage requirements and low efficiency. What ERC is that? ERC 721. So this lets you create NFTs. ERC 721 allows for the development of NFTs on the Ethereum blockchain. This is also what you would buy and sell currently on the Flow blockchain. So we'll probably still go for another like 5 minutes, and then I'll give you guys a chance to ask questions. There's still quite a few things that we're going to talk about. Not too many things, but a couple more. But ERC 721 is definitely important. So these are basically NFTs. So when you see ERC 721, that is an NFT. And it allows a holder to transfer tokens and also approve a person to buy and sell that token. And also allows for royalties and a couple of other things. So every token has a unique set of values with ERC. And when you own an NFT, the value can go up or down proportional to other currencies, but its value remains the same. So one NFT or whatever will be the same NFT, but it could one day be worth $500, the next day be worth $1,000. ERC 721 standard protocols are an interface, and they have to be implemented for any smart contract which wants to create NFTs. And you can also trade ERC 721 tokens for Ether, just like ERC 20 tokens, which are ICO, which are like shares of a company. But they can't use AMM algorithms because each one has its own unique properties, obviously. So these things are traded on auctions. They're exchange on NFT specific peer-to-peer marketplaces. The most famous one is OpenSea. So we're probably not going to get too deep into the NFT marketplace. Maybe later. Right now, we'll probably focus on development because that's more like a fun thing, which doesn't really have any like direct impact on development. That's more on the user side of things. So maybe in a couple months or something, we do just a short session on like NFT marketplaces and stuff. New economies for collectibles. It also helps with workflows. So ERC 721 identifies the owner's address and approves transfers and allows the person to receive the tokens. Every address which wants to receive a transfer has to be accepted. It has to be ERC 721 address before the transaction is conducted. And so when you do that, then you can transfer the NFT. So what are the use cases? Gaming, collectible, utilities, and resource access. So we kind of talked about NFTs and situations around NFTs. There's another ERC 721 slide. That might be it. Yep, those two. So I think that's a good logical stopping point. I think the ERC stuff is kind of is a bit much. So I'll give you guys 5 minutes to ask questions. If you guys have any questions, ERC.
So do they use the ERC 721? Actually, let me rephrase that question. Do you have to pay to do a workflow, or do you pay just to stake?
So the workflows are defined by the actual ERC standards, and it helps you to structure your smart contract and DApp deployment. Now, for staking, if you wanted to stake, then you would probably, most likely, I'm not 100% sure, but you would need the actual native token, the cryptocurrency, of whatever blockchain it was.
Yep.
I don't think they would allow you to stake NFT because their values are shifting all the time. So you could run into a situation where when you start staking, that you have enough, but then as you go through the time, then the value decreases, and that could even like be artificially manipulated somehow. And then now you have somebody who's validating a block who has no stake in the network, and then that's a recipe for disaster.
Interesting. Okay. Thank you.
But yeah, Flow interfaces is compatible with these. So you can go and take your Ethereum tokens and just stick them right on a Flow wallet. They'll still be available on Ethereum. It's not like they're taken off, but you can just buy, sell, do whatever you want with them on a Flow wallet. So that's kind of their vision, is this integrated future web where all of your assets, your virtual assets, and maybe even your physical assets and your cryptocurrency, which is your financial assets, and even your private personal information is totally controlled on your Flow wallet or whatever, which is on your local device. And then you have the public key and the private key, and you can give it and take it away from whoever you want whenever you want. So you don't like how Facebook is using your data? Well, you just remove Facebook's access to it because you're the one that actually had the access to it the whole time. So this is kind of how they're seeing things. And then stock ownership, obviously, you don't need a broker anymore. You can just buy and sell stocks however you want. Digital art, I think digital art is kind of dumb, but a lot of people are making money off of it. So I've thought about taking up drawing again because I used to draw in my youth.
Here's an odd one. So how does the use of crypto or NFTs tie back into stuff that goes on in the metaverse?
Yeah, that's actually one of my main concerns, and I lose sleep over this, is the metaverse. So there's definitely a huge push for a lot of companies to integrate with that, and this definitely will also integrate with that. Because
that's why I'm asking this question, because I see, like, here's why I was asking the question. I see what it is that Flow does, tying it, like that is a real world scenario for use in the metaverse, owning digital assets, which are driven by NFTs, right? Not the crypto per se, but really NFTs.
Yeah, there's no doubt that this is definitely going to be like a major thing in metaverse. It's gonna happen for sure, because this would be the best way that already exists to track ownership, especially if people are worried about Facebook and their privacy concerns. Well, this would be an easy way for them to say, hey, look, this is decentralized, you have total asset control, so on and so forth. So yeah, it would definitely tie in, because you would have your virtual clothes as an NFT, which is on the Flow blockchain, or whatever virtual assets that you own. What scares me about that is, do we really need to bring more of our lives into the virtual space?
Well, yeah, that goes without saying. Yes, yes.
So that's my concern. Are we going to end up in the Matrix on the side of a hill, and the robots
the
are
red pill or the blue pill? You pick.
Yeah, that's one of my concerns. But that's it for today. If anybody else has any questions, you know where to find me.